Hi everyone, welcome to this demo lecture on constructing suffix arrays. So the agenda today is to basically first I'll be going through what a suffix array is. So it's basically a sorted, it's a list of the uh, starting indexes of the suffixes in a way that they are sorted in increasing order of their lexicographicity. And the agenda for the demo is that I'll be coding two algorithms. The first algorithm is the naive algorithm and the second one is the prefix doubling algorithm, and we'll be comparing the runtime of both the algorithms. So that will give you a feel of how why more efficient algorithms are important to process big data. And let's begin. So first of all, I'll be importing some important modules that will be using during the code, like as a part of our code. So first of all, I will import the time module for mapping the time. Next, I'll import the random module. So it will help me to generate a random string that I'll be using as a part of the algorithm. And last, I'll be importing the math module, which will help me use some of the functions that I'll be needing during the course of my code. So I'll restart this kernel once. Okay. Next, I'll be first of all showing you the running the algorithms on a small input that is being taught in the course, like on the example Mississippi, and then we'll be moving on to a bigger example. So I'll so our string right now is Mississippi, and we have a delimiter in the end, and the length of the string, that is n, is basically, so we can print the length even. So as you see, the length is 12, and next I will be showing you the naive algorithm over this input. So the naive algorithm is the prefix is the basically you store all the suffixes in a list and you sort the list based on the custom inbuilt function that Python supports. So I'll be iterating over the string first, over the length of the string, and I'll be having a list that I will call as L suffix. Initially it's empty, and then in the while iterating I'll be appending a tuple where the first index of the tuple is basically the starting point of that suffix, and the second index is that suffix itself. So you can represent the suffix using this notation in Python. After you are done appending, you can just call the custom sort function in Python, and it works like this. Now since we are not sorting a list that is composed of a single element, but it's a tuple, so we need to use a custom sorting function, and the way to do it is like you can so it's using this lambda function and lambda variable. So what we are representing using this line of code is that you have to sort it based on the first parameter of this tuple, that is the suffix. Okay. After you are done sorting it, what you can do is you can first of all, okay, so basically this is the entire naive sorting algorithm. You append the suffixes and you sort it. So, in order to map the time, I will have a variable start and end that will map the time of the the algorithm takes to run, and next what we can do here is that along with finding the time, I have to also find the basically the suffix array. That is what I am supposed to print as well. So, that I will be storing in this list suffix array 1, and I can iterate over this sorted suffix array L suffix and pull out the values from that based on its first parameter. So, I in range n. So, suffix array 1 dot append L suffix, and you can pull out the value based on its first parameter. First means the 0th, basically the 0th index parameter, and but you can then after that print it as well. So, this will print my result as well, and then finally I will also print the time that this algorithm took. So, this can actually be represented using this these line of code. Okay, so we are done with the naive sorting algorithm. Now I will run this cell, and 1 second. Okay. So, as you can see, we get the suffix array values as 11, 10, 7, 4, 1, 0, 9, 8, 6, 3, 5, 2, and you can compare it with these values. So, you can see that they exactly match 11, 10, 7, 4, 1, 0, 9, 8, 6, 3, 5, 2. Okay. So, basically what we are getting is correct. This is an indicator. So, this basically there is no bug in the code, and the time it took to execute it is around 0.2 milliseconds. So, next we will be running the prefix doubling algorithm over the same input and checking the time it took, and also whether the output is matching with this naive algorithm. So, we will be sure about the fact that at least the code is correct, and then we will be running it over a bigger input and benchmarking the two things. So, now in the prefix doubling algorithm, I will first go through what so basically we won't be sorting the entire suffixes. We will be sorting only some chunks of the some fixed length prefixes of those suffixes, and basically the length is basically a power of 2, and based on the previous order we will be inferring the order for the next bigger block. So, this is a slide from the course itself. For example, here using blocks of length 2, I am getting the values for blocks of length 4. So, for doing that, what I will do is, first of all, let us have this, let us time it, and then I will be storing it in a list called data, and this list will have, so basically it is a 2-dimensional list where the first dimension is of size 2. So, in order to do that, I will append these empty lists into the data list, and there can be there can be a easy way to do this, but like in order to code this seems much simpler to, like this, the allocating the memory this way seems much simpler to me. And then as so basically the way prefix doubling works is, we have to execute the update for login iterations. So, we get the value of login using this math library, and so after that, as taught in the course, we also need to save the values of the inverse suffix arrays. So, that I am storing in the list called order of size n. After that, now basically I will be using, I will be toggling over the data list. Basically I will be updating the first list, the 0th index list first, and then the first index list first, next, and then coming back to 0 and then moving to 1. So, basically this helps to save the memory rather than allocating login space in that particular dimension. We can only do the update with 2 lists. So, in order to do that toggle, I have a variable called it. So, now what we need to do here is that, first of all, we need to append all these suffixes and their corresponding initial order in this data list, and the way to do it is, I am creating a basically a tuple where the first value is the starting point of that suffix, and the second value is also a tuple that represents the order. So, I represent it using and so what is happening here is that I am so using this order function, I am calculating the order of the order, basically the ASCII value of the ith character in string t, and I am subtracting it with the ASCII value of a small character a. So, and that will give me the initial value, and the second index here is 0 because we have not computed it yet, but for the further iteration it will be useful. So, now we can just, so now rather rather than doing a nice sorting just by just calling the Python inbuilt sorting function, we will have to process this sorting in a different manner that will look ahead in this course, look ahead in this code. And so, I will define this how to sort it. So, I will use the same order list that has been declared globally, and what I will do here is I will be sorting this based on the using a lambda function, where I sort this variable x first based on the 0th parameter and then based on the first parameter. So, the point here is, if the first parameter of the two tuples is same, then it will sort it in increasing order of the second parameter. So, I will come why I am declaring this particular variable. So, now I iterate over basically we have already sorted it, but we have to again update the inverse suffix array, and the way to do it is that all the values that have the same second parameter, right, in the data list, they should also be allocated the same value in the order list, that is the inverse suffix array. So, what that means is that if the prefixes of the two suffixes are the same, then those two prefixes should be given the same priority, which you will not be able to do if you just run the normal sorting. So, basically you have to do some extra processing on top of the normal sorting. So, the way I will be doing it is that if it is not equal to the key, then basically I update. So, I update I will allocate a new value to this index, and I will update the key. And the order here is data J0. So, that actually gives you the index of that particular suffix, and the order for that is this previous, this value that I am using to update the order. Now, once we are done with this, what we need to do next is we have to update it for the login iterations, and just for the like, since the code almost remains the same, what I will do is I will copy a part of the snippet from what I have and just explain. So, what happens here is I am iterating for the login iterations, and this time I will be toggling the value of the it variable, and I will be first of all clearing that list, and then for all these indexes I am appending to this list the index of the suffix and the corresponding order values. So, as you must have seen in the course that you can infer the value of this particular order of this particular suffix using the pre-calculated order values. So, this will represent the value at that particular index and the value after 2 raised per ith index. So, you sort it and then so now I will be storing the suffix, I will be getting the suffix array values from this sorted so the sorted list, and how I get it is that I will be using the inverse suffix array, that is order array, to infer those values. So, I minus 1, because these order values will be from 1 to n, not from 0 to n minus 1, because I am so basically this variable will start from 1 and not 0. So, just to for the sake of like the results remain same as compared with respect to the naive algorithm, we will subtract 1 from here and we will get the suffix array values. And now, since we are done with the code, we will find the time, and so let us first of all check that the suffix array value that we got for the prefix doubling is same as the naive algorithm, and looks fine. So, as you see that this is a tick indicates that the code ran successfully. You can even so next we will be finding the time that the prefix this algorithm took. So, and that is basically I will run it again just for the. So, it took around 0.5 milliseconds, and so it is comparatively more as compared to the naive sorting, because the complexity that you look for the prefix doubling, it is in the asymptotic case, that when the input turns out to be very large, right. For the smaller input, just because there are a lot of operations happening here, and because of another reason that the custom sorting function of Python is optimized, will be very optimized. So, that is why the time taken by the naive algorithm is less. Next, I will run these two algorithms over a bigger input and check the time. Okay. So, I will just restart the kernel again. So, we will again import the same modules, but here rather than having this string, I will have a random string. So, the way to do it is that I will have a empty dictionary and then I will fix my length out to be 2 cross 10 power 5, and that is around 2 lakhs, that is 2 lakhs basically. So, then now we use the random function from the random library and random function from the random library, and we append the delimiter and we update the length of the string to be this new length, and you can print the length as well. So, one second. Okay, it's better to declare it not that way, but this way. Okay, so the length is correct. Now, it's a string over just 4 characters ACTG, and these are the characters that are present in the DNA as well. So, we will run it over the naive algorithm, but before running I will not print these suffix array values, because the list will is already too big, and there is no way you can actually verify it as well. So, I will run it, and the time that it takes is, it's better to get the time here. It will take some time because we are appending all the suffixes of this, and that is basically quadratic. So, the space will the space requirement here will be a lot. So, it took around 18.24 seconds, and next just to clear up the space and so that the kernel does not shut down ahead, I will just clear this list. Next, we run this bigger input over the prefix doubling algorithm and check the output. So, the code here remains same because I am not printing anything, and I am just verifying that the output is consistent with the naive algorithm. So, let us run it. So, it took 4 seconds, and as you can see that is a lot of difference as compared to 18 seconds, and that is just for a string of length 2 lakhs, and the original DNA string is around 3 billion characters. So, in that case this difference will be much more prominent, and whereas the naive algorithm will take in like maybe it may take hours or even days, the prefix doubling will be able to sort the suffixes in much faster manner. And as I mentioned before that I am not using radix sort, I am using a nice sorting algorithm. If you use radix sort, then the time will reduce further. So, I hope this demo was interesting for everyone, and here we can conclude the same. Thank you.